This lecture is on the Heckscher-Ohlin model of trade, also known as the HO model or the factor proportions theorem. In our last lecture, we considered the specific factors model of trade as a short-run situation in which some factors were specific to particular industries. This model we'll be looking at, the HO model, does not assume any factor specificity. As a result, it could be considered as a long-run version of the specific factors model. However, the dynamics that drive comparative advantage here are different. In this model developed by economists Eli Heckscher and Heckscher-Ohlin, comparative advantage results from the differences in initial factor endowments across countries. The model includes a laundry list of assumptions with interesting conceptual definitions that you need to understand in order to make sense of the dynamics at play. As before, we assume two countries, the United States and India. In particular, we assume that one country is abundant in a particular factor and the other country is abundant in the other factor. Consequently, we assume that there are two factors of production, which are assumedly mobile across industries. We assume there are two goods, cloth and machines, that can be produced by employing both factors. And further, we assume that one of the goods, in this case machines, is capital intensive, and the other good, cloth, is labor intensive. Further assumptions include unrestricted trade in final output occurs across countries, technologies used in both markets are identical and reflect constant returns to scale technology, perfect competition holds in all markets, and tastes are similar across countries regardless of their levels of development. Now let's define those concepts of factor abundance and intensity for added clarity. A country is considered to be labor abundant if it has a higher labor to capital ratio, or equivalently, if it has a lower capital to labor ratio than the other country. By design, if that first country is labor abundant, the other country is therefore capital abundant because it will have a higher capital to labor ratio. With factor intensity, on the other hand, we say a good is capital intensive if it uses a mix of relatively more capital per unit of labor in producing a unit of that good, compared with the mix of capital per unit of labor used in producing the other good. Again, this implies that the second good will therefore be labor intensive. Let's illustrate these concepts. First, factor abundance. In the table on this slide, we have two countries, country A and country B. Country A has resources or initial endowments of 10 million units of capital and 400,000 workers or units of labor. Country B has 20 million units of capital and 2 million units of labor. The capital to labor ratio, that is, the units of capital divided by the number of workers, is 25 in country A and 10 in country B. This means that country A is capital abundant or labor scarce. On the other hand, the labor to capital ratio, that is the number of workers divided by the units of capital, would give country A a value of 0.04 and country B a value of 0.1, thus making country B labor abundant or capital scarce. Now, factor intensity. The table shows us the mix of inputs or resources that are used to produce both cloth and machines. To produce a yard of cloth requires, in this example, 6 units of capital and 4 workers, whereas it requires 15 units of capital and 3 units of labor to produce a machine. The capital per unit of labor and labor per unit of capital values for both goods are shown. Machine production is capital intensive since it requires more units of capital per labor to produce a machine than it takes to produce a yard of cloth. And similarly, the labor per unit of capital is higher in cloth production than in machine production, making cloth labor intensive. Okay, now we hopefully understand these concepts. Let's discuss how the possibility of mutual gains arises from the assumptions of the model. If we assume that the United States is capital abundant and machine production is capital intensive, then the United States PPF will be skewed toward more machine production than otherwise. And similarly, India will be labor abundant, and because cloth is labor intensive, India's PPF will be skewed toward relatively more cloth production. However, because preferences and tastes are assumed similar across countries, their social indifference curves will look similar, but will be tangent to their PPFs at different slopes. Thus, the resulting relative price of each good under autarky will be different across countries. This is depicted on this slide. As drawn, with cloth on the vertical axis and machines on the horizontal axis, the United States PPF is skewed toward more machine production, while India's PPF is skewed toward more cloth production. Thus, with similar shaped social indifference curves being drawn in both planes, the point of tangency of the highest possible indifference curve with the PPF in each country occurs at a point where slopes are different. Since the slope of the line tangent to their points of tangency is given by the pre-trade relative price of machines, then as drawn, it is smaller or flatter in the United States than in India. We now have the necessary price differential that makes trade mutually beneficial for both countries. This leads to the factor proportions theorem, which states that a country will have a comparative advantage in producing a good that is intensive in the factor in which it is abundant. The intuition for this is straightforward. The abundance of a factor lowers the relative price of that factor. It therefore becomes advantageous to produce more of the good that uses a lot of that factor in its production. That is, more of that good can be produced at a relatively cheaper rate compared to the other country. Hence, a comparative advantage in producing that good results. In our illustration, the relative price of machines is flatter or smaller in the United States compared to India, the result of the US being capital abundant and machine production being capital intensive. This is explained analytically by what happens to the relative factor payments due to factor abundance. The relative rental to capital, that is R over W, in the United States is lower than the relative rental to capital in India, R star over W star. Note that the relative rental simply gives the ratio of the payment to capital or the rent to the payment to labor or the wage. I could have alternatively looked at the relative wage, in which case I will be looking at the ratio of the wage to the rental, that is W over R. The cheaper relative rental results in the lower relative price of machines in the United States, that is PM over PC is less than PM star over PC star. Thus, the United States has a comparative advantage in machine production. By analogous reasoning, India has a comparative advantage in cloth production. That is, the relative wage is lower in India than in the United States, and so PC star over PM star is less than PC over PM. So we trade now between both countries. The analytics and results are similar to how we have described previously. Specialization will happen in the direction of comparative advantage, but will be incomplete. Gains from trade will follow through attainment of higher consumption possibilities, which are unattainable under autarky, but now made possible through trade as a result of changing relative prices. However, there will be within-country distributional winners and losers from trade, but not as in the specific factors model. The analytics of this are given in this slide for the United States side of the trade picture. Trade causes the relative price of machines to rise in the US until it converges to a global price PM over PCG, where India's relative price of machines has also fallen to. Machine production increases in the United States, while cloth production decreases. However, for that to happen, the relative rental in the United States, that is R over W, has to increase. This follows intuitively because the shrinking cloth industry is giving up more labor per unit of capital, whereas the expanding machine industry requires more capital per unit of labor to produce. So trade causes capital to be relatively scarce compared to labor in the United States, such that the relative rental R over W increases. The end result of trade is therefore that both relative prices and relative factor payments converge across countries. The welfare effects of trade alluded to earlier can now be seen and is summarized by the so-called stolper-samuelson theorem. It states that in the long run, an increase in the relative price of a good will increase the income share of the factor that's used intensively in its production. To be sure, total incomes in both countries increase from trade, but the corresponding distribution within each country creates winners and losers. As a result, we can see that in the United States, owners of capital gain from trade, while owners of labor lose. Similarly, in India, the owners of labor gain and owners of capital lose. We can walk through the technical analytics that explain this outcome, and here we focus on the United States. This content is not for the faint-hearted. Okay, we can write the total supply of capital as K bar being equal to the sum of capital used in machine production and capital used in cloth production, and similarly the total supply of labor, L bar, as the sum of labor employed in machine production and labor employed in cloth production. The total relative capital, or K bar over L bar, can therefore be decomposed into the components as shown. With a little algebraic manipulation, we find that the total supply of relative capital is equal to the weighted sum of relative capital used in the two industries, where the weight for each industry's demand, or relative capital, is given by the share of the labor force employed in that industry. This is depicted in the graph on this slide. Plotting the relative rental on the vertical axis and the relative capital on the horizontal axis. The relative rental, R over W, is the price of relative capital, K over L. The total supply of relative capital is fixed, being determined by the quantity of each in the United States, and its value is therefore a straight line that shows it is invariant to changes in the relative rental. The different industry level demand for relative capital are seen, with the demand for relative capital in the machine industry, Km over Lm, being higher than the demand for relative capital in the cloth industry, Kc over Lc. The reason for this is because machine production is capital intensive, so at each relative rental price, the demand for relative capital is greater in machines than in cloth. The red demand line between the two is the weighted sum of both demand curves given by the equation in the previous slide. If it is closer to the demand for relative capital in cloth, then it means that many more workers are working in the cloth industry. That is, Lc over L bar is greater than Lm over L bar, and vice versa. The point of equilibrium that gives the relative rental is R bar over W bar, and is found where this weighted demand curve intersects with the vertical supply of relative capital curve. That is, the autarky relative rental given capital abundance and factor intensity in the United States. With trade, as PM over PC rises, Lm increases and Lc falls, as cloth production shrinks and machine production increases. The weights are now biased towards the demand for relative capital in machine production, and this shifts the weighted relative demand for rental function up. The result is that the equilibrium relative rental goes up. This is demonstrated in the graph as a resulting shift in the red curve up to the blue curve. Note that there are several arrows in this diagram, showing us that a number of things are happening as a result of trade. First, the higher resulting relative rental causes a movement along the industry level demand curves, showing that capital over labor falls because the higher relative rental makes relative capital more expensive. However, because the total amount of relative capital supplied does not change, it means the changes in the weights somehow offset these losses. So what do these changes mean for real wages and real rental? First, for real wages, we know that the real wage is given by the marginal product of labor. Trade causes capital-labor ratio in each industry to fall. That means we have less capital per unit of labor, so the marginal product of each worker, the MPL, falls. Real wages therefore fall and workers are worse off. Second, for real rental, we know that this is given by the marginal product of capital, the MPK. If the capital-labor ratio falls in each industry, that means each unit of capital is now more valuable than before, as each worker has less of each than previously. So the marginal product of capital increases. This means the real rental increases and owners of capital are better off as a result. We focused on the United States, but we can extend the same analysis to India, and we see that fortunes are reversed in India by an analogous argument. Real wages increase in India, making workers better off, and the real rental falls in India, making capital owners worse off. Let us now introduce a numerical example that demonstrates these central results. As the table shows, we assume a HO model scenario with cloth and machines and factor intensities as described previously. We focus here on home and assume it is capital abundant. Pre-trade prices and wages for both goods and industries are given. The total output and values for labor are also given. Finally, we have post-trade prices. These simply capture the fact that factor abundance and intensity give rise to a post-trade relative price of machines that's higher than the pre-trade relative price of machines. In our illustration, this results in 1.2 as the post-trade relative price of machines being greater than 1, the pre-trade relative price of machines. We now investigate what trade and the resulting price and income changes mean for the welfare of those within home. First, we can compute that machine prices have increased by 12.5%, whereas cloth prices have fallen by 6.25%. Now we have the production function set up so as to be able to determine the impact on wages and rental income. So as before, total output is equal under computation to the total factor payments. This holds in the two industries. Again, with a little algebraic manipulation, we have the change in the rental income being expressed by two equations that are functions of the change in the wage rate, as other variables are known and can be plugged in. So we plug in the known variables and solve the simple two equation in two unknown simultaneous equation and see that post-trade wages fall by 25% and rental income increases by 125%. The results again confirm our prior theoretical exposition. Owners of capital gain as their post-trade incomes increase by 125%, whereas machine prices increased only by 12.5% and cloth prices fell by 6.25%. Owners of labor lose as their post-trade incomes fell by 25%, whereas machine prices have increased by 12.5% and cloth prices fell by only 6.25%. We can again think about the possibility of redistribution, where those who lose, in this case workers, are compensated fully for their losses by those who gain, in this case the owners of capital. To investigate this, we assume that the pre-trade rental income is $20. We then compute the pre and post values for real rental in both goods and real wages in both goods. We see that the sum of the gains from higher real rentals can fully compensate the sum of the losses associated with reductions in real wages, and there's still a net gain of $26.25 left over each period. Again, this can further be split in any way such that all parties become strictly better off compared to the situation under autarky. While this model provides interesting theoretical insights, and in many cases does drive our understanding of the gains from trade in a more realistic multiple resources setting, the initial attempt at empirically validating the model turned up a paradox known as the Lone-Thief paradox. The paradox essentially states that US industries with trade surpluses were found to be more labor intensive than US industries with trade deficits. This meant that the US seemed, contrary to what the HO model would suggest, to be exporting more of those goods it had a comparative disadvantage in, since the United States by comparison was considered capital abundant and should have been exporting more those goods it was capital intensive in. Subsequent research, though, seemed to find a way to explain away this paradox by demonstrating that in practice the factor proportions theorem still held when 1. We controlled for other factors other than labor and capital, 2. We make a distinction between skilled and unskilled labor, and 3. When we take into account that the setting was not fully adequate to test the HO model. At the time, in 1954, protectionism was more rampant, and so there was restricted trade, which violates one of the HO model assumptions. We can now summarize what we've learned in this lecture. With multiple factors and long-run factor mobility within each country, there are still gains from trade, and this is due to differences in initial factor endowments. However, trade still brings with it distributional implications in the form of class warfare. In this case, labor is pit against capital owners. The gains from trade still allow for redistributive policy that makes all parties strictly better off, and this is where policy should be focused instead of restricting trade. Next steps will include making sure you fully understand this content by reading through chapter 4 of the text, then taking the quiz associated with this lecture, though you could do this first or at the same time. The next lecture looks at new trade theory, and this is chapter 6 of the text.